Hi, I'm Andrea from AWS.
And I'm Marco from Turnitin, and this is my architecture.
So we're here to talk about an event-driven architecture that focuses on academic integrity. What is that?
So the use case is to be able to detect generative AI writing in the academic world, and so using education technology.
Awesome. So this is on AWS.
Yes.
And let's walk through a workflow.
Sure.
I'm a student. I want to upload my paper onto your platform. So let's go through the example. What's the first thing that happens?
So the student, here's our user, would upload it to Turnitin, our website, either through an integration or directly. And that will fire an SNS topic to indicate that a paper has come in and it's ready for processing.
I see.
And then we have an SQS queue, of course, that consumes that SNS so that we now can queue it up and get ready for processing for the generative AI detection.
I see. What's the scale? How many papers are you processing?
So we are processing up to 2 million a day.
Wow.
Pretty much day after day.
Okay. So you're storing these in the queue. Yes. What happens next?
So next, we have a Lambda that will pick up the messages from the queue and determine if we are processing. We don't process 100% of the papers. There are some papers that we choose not to process because of language, because of size limitation. If it's too short, we don't process it. And also, if it's too long, we don't process it. And so once it determines it processes it, it will pass it off to a second Lambda that is going to look at the document and handle breaking it up into sentences and also remove things that are not what we call prose. So it's only the actual writing, so things like headers and footers and all that get removed.
So the architecture pattern here is the first Lambda function is almost your rules engine.
Yes.
Right? And then the second one breaks the sentences up.
Correct.
And then from there, what do you do next?
So then the second Lambda will send a sliding window of sentences on to a SageMaker endpoint to do the inference of that number of sentences. And it does that in parallel. So it'll send about 10 segments so that we can get, just for performance reasons, we don't have to wait for each one in turn.
With the scale that you have with this, you mentioned 2 million papers a day. What type of Lambda components are you running? Is it serverless or are you running EC2?
We were hoping to use SageMaker serverless, but the scale, the current limitations prevented us from doing that. So we had to use SageMaker EC2 to get the concurrency we needed. Even though we have a queue, it would just fall behind if it can't run at full speed.
I see. So you have a machine learning model that does inferencing.
Yes.
So what do you capture?
So the machine learning model does the inferencing for the segments of sentences, and it will return that back to the Lambda that asked it. And this Lambda will aggregate each segment to come up with a score for the document. So at this point, we have a score for every sentence and an overall document score.
I see.
And that gets returned to the first Lambda. I should point out, obviously, it's non-standard to have a Lambda calling a Lambda. And we do that intentionally because the first Lambda, the orchestrator, the rules engine was written by our production team. It better suits itself to being in Java because we already have the libraries and everything to do this. The second one was written by our AI team, and it's written in Python. So it's hard to combine Python and Java. And so we went ahead and just did it separately because this logic more closely relates itself to the model. So we had to do that, which still works out, even though slightly unstandard.
So the architecture pattern you followed here is to help data scientists and those in the back end kind of work collaborative together. Is that because you wanted to persist the data?
Correct, yes.
Somewhere?
Because then this Lambda will finally persist the data in Dynamo. And again, we have all the libraries and all the patterns written for that. So that in Dynamo, we end up with a record for every paper at the sentence level, for all the details stored in there. And then finally, we have a micro front end, which is a web component, which we were able to embed in all our existing applications. And that way, we didn't have to rewrite all the application. You could just embed the web component. And this micro front end is able to call the Lambda to retrieve the data for that one document, to be able to display it to the instructor, the indicator, and the various data needed.
So the score per sentence and the document and papers and the rules are persisted in DynamoDB.
Correct, yes.
And then the teacher can then acquire that information through their web front end.
Exactly. And then we were able to release this to all of our customers who opted in. So a few opted out, but we were able to release it to everyone worldwide, literally overnight, by able to inject it.
Wonderful. And Marco, in terms of locality, do you offer this in North America?
Yes, this is geo-distributed. So we have this system repeated 3 times in Europe, in Asia Pacific, and in the US for the customers based on their geography.
Awesome. I really love this architecture. Thanks for sharing this event-driven architecture with this unique pattern.
Thank you very much.
And thanks again.